Okay, hi. So 11.4 was about cross product. And basically what cross product is it creates a third vector that's orthogonal or perpendicular to two original vectors. So it's represented by this cross over here, u cross v. So u and v would be two different vectors, and we can represent them using unit vectors. So this and this. And the first step to finding the vector is to write it as a matrix. So you write it with the unit vectors in the first row, then the u components of the u vector, and then the v components of the v vector. And then you have to find the determinant of that, and there's two ways to do that.
In the first method, you have your original matrix, and then you bring down the first two columns next to it. And then for the first part, you would go downwards diagonally. You would multiply each component and then make them positive. And then when going upward diagonally 3 times, you would multiply them by each other and then subtract. For example, in the first column, when going down diagonally, you do u2 times v3 times vector I, and that would be positive. And then in the end, you'd collect the like terms.
And then for method 2, we're going to set up our original matrix in the same way, and we're going to split this up into 3 smaller matrices. And to do this, we're going to first cover up both the row and the column that I is in. And when we do that, we're left with u2, u3, v2, and v3. So over here, we would write vector I and multiply that by the matrix u2, u3, v2, v3. And we're going to do the same thing to j and k, just cover it up like that to see what should be in the matrix. And also, when you're doing this method, the signs have to alternate. So in method 1, you would add everything together, but in method 2, you would have to subtract the j part and add the k part. And from there, you do the same thing as method 1. Multiply the diagonals, make the downwards diagonals positive and the upwards diagonals negative, and combine like terms. And then when you found your third vector, to check if it's orthogonal, you would take the dot product of each original vector and each new vector, and that should equal 0.
Okay, so the first example, we're using vector u as being 7, 3, negative 4, and we're using vector v to be 2, negative 8, and 5. So we first, okay, so we first bring the 2 rows over here and write them on the side so that we can multiply it out. So we take I, 3, and 5, and that's I, 3, and 5 is positive, we multiply that, and then j, negative 4, and 2, and then we add that, and we also add k, 7, and k times 7 times negative 8, but then we subtract going upwards, so we subtract 2 times 3 times k, the k vector, that negative 8 times negative 4 times the I, and and 5 times 7 times the j. And then you add all of them together and combine the like terms, and you get negative 17i minus 43j minus 62k.
So we can also find the new matrix, the new vector using the second method. So we create 3 new matrices, first by covering up the I row and column, and then covering the j row and column, and then covering the k. And we remember to alternate our signs. So we find the determinant for each of these new matrices, and we get the same answer as before, negative 17i minus 43j minus 62k.
Okay, and then we want to check if the vector is orthogonal, and so we take the one that we found using both methods, and we got the same answer, and we multiplied that first by the u vector. We did the dot product of times the u vector, and we got that it was equal to 0. And we did the same thing for the v vector, and we also got that it's equal to 0, so that means that this was orthogonal to both vectors.
Okay, and then there's also a geometry application for all of this. So if we want to find the magnitude of u times v, there's basically this formula for it over there, which is the magnitude of u times the magnitude of v times sine theta. So we drew a picture over here to represent that. So basically this is finding the area of the parallelogram because it's v times u, but this v sine theta is solving for this height. So once we multiply v sine theta times u, you get the area of the entire parallelogram. And that's basically it. Thank you.